Hi scientists! Here we are with our kinetic and potential energy review. So because we were talking about both kinetic and potential, we're also going to be talking about mechanical. Please make sure that you have your name on this as well as what period you have science, just in case it gets put in a weird folder on our drives. So you're going to want your vocabulary that will help you with this, and you are going to want your text packet, specifically the pages with the falling ball and the pendulum and the roller coasters. That will help you with this, as well as, if you have access to it still, your mechanical energy presentation that we had you do back when we were in class. Press pause and get those things. Press play to begin again. All right, so we are going to start with potential energy keywords. Look at all of your resources. Figure out what are the two main ideas for potential energy when something has only potential. Press pause and type them in. Press play to begin again. So hopefully you came up with height and not moving. If you did not have those two ideas, press pause and put them in. Press play to begin again. We're going to do the same thing with kinetic. So with kinetic, look at your resources. Find the two main ideas for having just kinetic energy. Type them in. Press pause and do this. Press play to begin. So hopefully you got the fact that it has to be moving and that it is moving flat, because if it goes up or down, it is mechanical. If you didn't get this, press pause, get these in, and press play. So now we're going to take these two ideas about height and not moving being potential and moving flat being kinetic and apply them to these pictures. So a bowling ball rolling toward the pin, kinetic or potential, and why, using these words. A rock sitting at the edge of a cliff, the skydiver picture that I cannot see, so maybe you can see. We'll check it out. He's sitting on the edge of a plane about to jump. The ball rolling toward the goal in soccer. A ball bouncing on top of a seal's nose, and skateboarding down the street. Press pause, fill in the kinetic or potential and the why using your keywords. Press play to begin again. All right, so the bowling ball is kinetic energy because it is moving flat. The rock edge is potential energy because it is up high and it is not moving. The skydiver getting ready to jump is potential energy because he is up high and hasn't jumped yet. The ball rolling toward the goal is kinetic because it is moving flat. Bouncing on a seal's nose, that ball has potential energy because it is up high and it is not moving. Skateboard guy rolling down the street, that is kinetic energy because he is moving flat. If you did not get this, you need to press pause, fix it, and press play to begin again. All right, so now we're going to look at this transformation. So right here, we need to figure out, what does it mean to transform? Press pause and put in some ideas and press play to begin again. So when we transform, just like the Transformers, when they change from cars into robots, to transform means to change. It means to turn into. So hopefully you have something like that. If not, press pause and fix it, and then we'll move on. So we're going to start with this bouncing ball. At first, it's up here at A, B, C, D, E, and F, and we're going to look at the total energy. So the total energy it has up at A is 10. Its potential energy is 10, which means its kinetic energy must be what if we add potential and kinetic together to get our total? Hopefully you've already thought to yourself that that kinetic energy must be 0, because 0 plus 10 equals 10. If we were doing this with colored pencils, we would take these bars and we would color all of them a potential color and none of them a kinetic color. However, digitally, it's not set up for that. Let's look at B. We are still going to have a total energy of 10. And now if you look at where B is, then think about, what would all of the kinetic be? What would all of the potential be in terms of numbers? Press pause to do this. Press play to begin again. All right, so hopefully you figured out that because it's at the bottom, it's 0. And the kinetic then has to be 10. Let's look at C. I don't know how to pause in a minute. Mr. Ziegler is here asking me a question, kiddos. I don't know how to pause this, and I'm 5 minutes in. Let's move on. So we have C. C is up here at the top, and if I look, C has a total energy of 8. So at the top, what does it have for potential? What does it have for kinetic? Press pause and type them in. Press play to begin again. So because it's at the top of its bounce again, all of its energy is going to be at kinetic. So that's going to be 8, which means it has no more energy left for kinetic. Hopefully you're starting to see a pattern here. Let's do D now. D, we're also going to give a total of 8 because it just came off of its 8 energy bounce at C. So if it's at the bottom of its bounce, no more height, press pause to fill in the potential number and the kinetic energy. All right, so all of it should be kinetic now, so none of it can be potential. Let's go to E. E is at a total of 5 for its energy. It's at the top of the bounce. Press pause and fill out potential and kinetic. Press play to begin again. All right, I'm hoping you found the pattern that when it's at the top of the bounce, all the energy is potential, so it has no energy left for kinetic. Finally, we are at F. F just came off of our E bounce, so we'll say it has a total energy of 5. Press pause and fill in the potential and kinetic. Press play to begin again. All right, so this time it's at the bottom of the bounce, so none of it is potential and all of it is kinetic. Now, let's look at our roller coaster. This gets a little bit more complicated. It's not all potential and it's not all kinetic for every single picture anymore. So, we're going to start up here at A. A has a total of 10. It is at the highest point. It's going to have that split-second pause at the top of the hill before gravity takes over and pulls you down. So, again, because of this one, our potential is going to be our whole energy and our kinetic is 0. Now, if we look at B right here, B is going down. It's moving and has height. We've already said that the potential energy is going to be 4. On a roller coaster, we are going to pretend that this is a perfect system and we are not losing energy anywhere. So our total is going to stay 10 for the entire time. So if I know that at B I have energy of 4 for my potential, what must my movement energy be? It must be 6 because 6 plus 4 equals 10. For C, I'm at the very bottom of my roller coaster. So that's why I have no height. But if I have no height and I still have a total energy of 10, what does my kinetic have to be? It does have to be 10. And then at D, it's like halfway high from what it started with. It's still moving. So at this point, I know that my kinetic energy is 5 from moving. My total is still 10. So what does my potential need to be? That one also needs to be 5. So hopefully, kiddos, all of this stuff is making sense to you about how kinetic and potential share the total energy of both a bouncing ball and a roller coaster. Last but not least, we are going to take a look at how this energy shifts back and forth and back and forth. So you see two similar pictures, the bouncing ball and then our roller coaster, except this time I've added a cart going up in addition to the cart at the top of that hill. So we need to figure out what type of energy now is at point A. Hopefully, if you scroll up here, you're going to understand which type of energy does A have. Does it have potential? Does it have kinetic? Or does it have mechanical? Press pause and do this. Press play to begin again. All right, so hopefully you know that at A, it's going to have potential energy because it has height and it is not moving. I want you to think about what kind of energy does it have at B. B is down here. And again, you can scroll up and look at B. Where did you put all of the energy? Into potential or kinetic? Press pause and type in B. Press play to begin again. So hopefully you got that this was kinetic energy. I would like you to go through and finish the ball, C, D, E, and F. Press pause to do it, press play to begin again. All right, so C is going to be potential. It has height and it pauses for a second. D is going to be kinetic because it's moving and no height. Then it goes back to potential. And then it finishes off with kinetic for our drawing. Now, we know that it has a different kind of energy on the way down and a different kind of energy on the way up. And we see that in our roller coaster one, because up here we were sharing the energy. Potential was at 4, kinetic was at 6 on the way down. When it was halfway on a hill, it had 5 and 5. So because it's sharing energy, it's not only one or the other, and we know that when it has both kinetic and potential at the same time, it really has mechanical. So we're going to take that mechanical idea and we're going to go one step further with it. At A, hopefully, we all know it has just potential energy. But now B, it's going down. So hopefully you realize from up here, having potential and kinetic, that means that it has mechanical. But we need to be more specific than that. We need to say it's mechanical energy, either potential turning into kinetic, it's getting lower and speeding up, or it's kinetic turning into potential. It is getting slower and higher. So when something is going downhill, it's getting lower, so it's losing its potential. So it started with a lot of potential, and it's getting a lot of kinetic. So we say it's mechanical energy, potential turning into kinetic, because it is getting lower and faster. At C, let's talk about what C is doing. C is at the bottom and it's only kinetic. So we are going to say that C has kinetic energy. Now D I made different. D is on the way up. So I know that it's moving and it has a height. So hopefully you're thinking to yourself, that must mean it has mechanical energy. But we again have to figure out what is turning into what. This time from D, it's starting all kinetic at C, moving towards potential up at E. So this time, it's mechanical energy, kinetic, turning into potential because it is gaining height and losing speed. Then at E, which was our old D up here, we said that it had both again. So if it has both, it's got to be mechanical. And at this point, we're not really sure if it's on its way up or down, so we just need to leave it as mechanical energy. All right, so we have this law of conservation of energy, which you read about in your text packet on pages, I think it was 123, 124. So it says, look at our total energies and what pattern do you see? And hopefully, just like with our skateboard, I see that the total energy stays at 10 for all spots on my roller coaster. What happens to the amount of potential energy as kinetic increases? What I'm hoping you notice there with the pattern is that as kinetic energy increases, potential energy decreases or goes down. They're opposites. One goes up, the other goes down. And that's what's asking here. What happens to the amount of potential energy as kinetic energy decreases? So as kinetic energy decreases or goes down, potential energy does something. Press pause and put this in. Press play to begin again. So hopefully you put down that potential energy increases because they are opposites. All right, you're going to take these answers and take a small quiz. Good job, scientists.